Now, I recently put together an FPV RC scale warbird. I used the FMS T28 Trojan 1.4 meter bird. Um, during that build, I hit some roadblocks putting it together. I use a flight controller with the Inav firmware, running a Spectrum receiver. Most people use an ALRS receiver or Crossfire. Uh, I couldn't find a lot of information, easily on the internet or, on YouTube. Everything that I needed, all the information I needed was actually in the iNav documentation, in their how-tos, but it just wasn't clear, to me as I was reading through it, because, there's that learning curve when you're trying something new. As you start reading it and you read it again and again, it starts becoming clearer, and then it's like, okay, I understand it. And then, once you start applying it, it all starts clicking into place, and then it's like, oh, well, that makes sense. And, then it just all kind of works. Well, what I'm wanting to do in this series of videos is, for those of you who don't understand it your first go around as you read the iNav documentation, as I want to go through this process in the videos of how to do it through, using the Spectrum. And you can also apply some of this, if you're going to do the ELRS or Crossfire, applying this in a scale RC warbird and not using a wing or something else, because everything that you read is you have to program everything through the Inav configurator. You can't program anything through the transmitter. There's not a lot of clear documentation on, all right, how do I configure the landing gear? How do I configure the flaps? How do I do all of this? Because it didn't make sense to me, because again, everything that I'm reading is, all right, we're going to be doing wings. Well, I want to do the landing gear. I want, flaps. I want things, things that are specific to the warbirds. I'm not looking to do, long range FPV. I just want to keep, my warbird basically in line of sight, but, in the FPV, because I'm not able to keep the plane in the air for more than, 5, 6, maybe even 7 minutes. So in this series, I'm going to go through everything that we use, and, how to put it together. So in this video right here, I'm going to quickly go over some of the hardware that I'm using, and then in the following videos we'll start through the process of putting it together, configuring iNav, putting it in the plane, and all the way through the maiden flight, and hopefully you can follow along and apply it to your build as well. So the first thing I want to show is the Speedybee flight controller. Now, we're going to be putting this in another T28. I'm going to be building the Eflite Carbon Z T28 2 meter. So it is another T28, but this is going to be a bigger T28 than I did before, which was the FMS T28 Trojan, the 1.4 meter. The T28 is just a fantastic platform. It's very stable. It has the tricycle gear. It lends to a I think a very good plane to start off in FPV scale warbirds for RC. But the first thing we want to focus on is the flight controller. Now, when you do FPV, you don't have to use a flight controller. So we need to get that out of the way. Some people opt to put them in there. Some people don't. I do. There's a lot of benefit of using the flight controller. When you use the flight controller, you get things like you can use the GPS. So when you're on your FPV goggles, you're able to get on-screen display. You're able to see with the GPS, you're able to get the ground speed. You're able to get your altitude. You're able to get your direction. But with the flight controller, you're able to do things like loiter mode, where you can flip a switch and the plane will just sit there and fly around in circles. Return to home function. There's a lot of cool things you can do with that. The flight controller is literally a computer that you connect everything to. It's central to the build. So I'm using the Speedybee F405 wing. So we're just gonna open this up and let you get a look at it. When you get it, you open it up, you have basically the instruction manual. And when you open, you want to go through this and read it, because everything really that you need to know on how to connect it is in this thing. You know, this will be my second build doing this, but there's 3 boards in here. The first board here is the power distribution board. This is where you're going to connect your ESC and your battery leads. This is going to be the middle board. It's the actual flight controller right here. This is a board here where you can put a micro SD card, which is the black box. It records all of your data. And this top board right here, this is I think it's the wireless, where you can connect to how you can connect to it with a Speedybee app from your phone. It's pretty handy. But there is some soldering that does have to happen. You'll have to solder your ESC and battery leads right in here. You'll have to solder your servo leads, not servo leads, but servo leads here. We'll pull this out. There's some things that come with it. You've got a whole slew of extra cables. These are very handy. These are how you connect the stacks together. And here's your servo. This is what you're going to have to solder to the boards right here. Also, the GPS. I opt to use the DJI O3 Air Unit. Is what I'm using for the FPV. And this will connect to this flight controller as well. You need to have the GPS for it to lock on the satellite, so that it'll arm to get full power for the DJI O3 Air Unit. The GPS that I'm using is the BZ251 GPS. It comes with a compass. Now, the last one that I used was a BZ, I think it was the 180 or 181. It was okay. It's kind of slow to lock on satellites. We'll see how this one does, and we'll go through the setup process of this and the videos when we set this up. For the receiver that I'm using, it's going to be the Spectrum 4651T, and it's an XL2 receiver. These are designed for it's a full range telemetry receiver. It's actually designed for flight controllers. It can do 20 channels. And you're going to need a lot of channels using the flight controller. I think on my last T28 I was using I think 12 channels is what I ended up using. So to be able to use like the return to home, you'll have things like auto trim, auto tune. There's different functions that you'll have in Inav. There's a lot of really cool features of being able to use a flight controller on Inav. There's for line of sight, for what we're doing with the Scale RC Warbirds, using for FPV. I mean, I have plenty of range. I've never had any issue with range, or knock on wood, of losing any signal. But it's been great. For me personally, I use the Spectrum IX14 transmitter. Programming is easy. I actually started on my first build. I was using the Spectrum NX10, and I had no issue with not having enough channels. But to use this receiver, you need to get this adapter cable right here to be able to plug this in. For this adapter cable to be able to plug this into the Speedybee flight controller. and I'll go over that in the upcoming videos and how that connects. Also, to be able to use the Spectrum receiver, there is in the command line of the Inav configurator, there are some extra commands you're going to have to put in there to make this work, to get the full resolution, and I'll go over that with you. It's not hard to do at all, but that was the one thing that I was struggling with when I first bound the my last build, when I first bound this receiver to the other build that I did. I was like, okay, this isn't working right. Why isn't this working? And I was struggling with it, and I wasn't getting any positive feedback from anyone. And when I was asking, they're like, oh, you need to go don't use Spectrum, go to Radio Master or FrSky, and use use ELRS, Crossfire. And I'm like, yeah, okay, I can do that, but I'm stubborn and I want to use Spectrum. I'm not doing long range. I just want to be able to fly, where I'm doing visual line of sight, but I'm going to be doing FPV. So it's actually not hard to do, and the documentation to set this up is in the Inav documentation, but we're going to show you how to do this in the videos. For me, this is where the real magic happens. This is the signature bag for the Motionsic BAG pan and tilt gimbal. Let me open this up. Okay, so what we have here, what's inside is the pan and tilt gimbal that the DJI O3 camera connects to in here, and we use a head tracker, motion sensing head tracker, that also comes from the same company. It's the FPVdogfight.com. It mounts to, for this version that I have here, I use the DJI goggles V2. It mounts to the side here. If you have the DJI goggles in Integra or the DJI goggles 2, they have another version that mounts to the front of the goggles. But if you have the V2 version, head tracker mounts right here to the side. And so what happens is when you're wearing the goggles, as you're wearing them, wherever you look, left, right, up, down, the pan and tilt gimbals, you get the servos here. The camera will, that's mounted in here, will it'll look up, down, left, right, and as you've seen in my videos, it gives you the perspective as if you're the pilot in the cockpit of the plane. It's a very surreal experience. It takes, in my opinion, it takes flying RC planes to a whole another experience. I used to fly general aircraft. I used to fly experimental and ultralight airplanes, and it's not the same thing. It's still missing a lot. You don't get the tactile feedback of being in a real plane. You don't feel the turbulence. You don't hear the wind noise. You don't get the vibration of the engines running. There's a lot that you're missing, but this is the next best thing. Your feet are on the ground, but in your mind and in your eyes, you're up in the air, and it's real time, and it's really amazing. And on top of that, if you have any dreams of aspirations or of flying, for me, I love World War II warbirds. You can slam this into your favorite warbird. Right now I'm putting them in the T-28s because that's a good platform to start with, but eventually I can see myself putting them in a Corsair or a P-51 Mustang, or you know, a P-47, you know, you name it, you know, people, you know, they're putting them in, you know, F-16s or, you know, any kind of jet, you know, F-18, something like that, you know, you choose, you know, as long as the plane can hold the gear, you know, it's whatever you want. So just have fun with it. Okay, and here's the Carbon Z T28 that we're going to be putting the FPV gear in. It is a large bird. I have yet to put the livery on. I haven't decided if I'm going to use what Eflite provided, or if I'm going to, you know, order something from Cali Graphics. I just haven't decided yet. Here's the inside of the Carbon Z T28. When I purchased this, I opted for the bind and fly. It did come with the Spectrum AR637TA receiver. I will be pulling it out, and I'll use it for some other project. But this is where I'll be putting the Speedybee flight controller. I will be getting some multiplex connectors to take care of this rat's nest in here. This is a mess, and that's not going to be something where each time I go to the field I'm going to be wanting to connect and disconnect all of that. That's going to be just too difficult. But there's plenty of room in here for everything. I mean this, you know, you can put a small child in here and they can take a nap. So yeah, we're good. So what I want to show here is the canopy. So in the canopy, where this little pilot is, this is where we're going to put the Motionsic BAG pan and tilt gimbal. That is where the DJI O3 Air Unit is going to be mounted. We are going to have to cut the clear canopy out. It looks pretty clear, like we would have, you know, no distortion, but it'll be pretty distorted in there. It's not cloudy, it is clear, but I just don't think it's going to be clear enough. I think, you know, just based on the type of plastic, if we had it in there, I think it would just be too distorted. So it's going to be cut out. I'm going to show you here in just a second on the FMS T28 that I did what it's actually going to be similar to. Okay, here's an example of the FMS T28 that we built. Right here is the Motionsic BAG pan and tilt gimbal with the DJI O3 Air Unit mounted to it. So there's the DJI camera and the O3 Air Unit back here with a fan. There's a fan on top because the O3 Air Unit gets really hot, especially here in South Alabama. It'll overheat. So this is what we're looking at. You can see that, you know, the FMS canopy is way more cloudy than the Eflite canopy. I had to cut it out, but even though the Eflite canopy is a lot clearer, I just feel it's going to be too distorted. So we're going to cut it out. And you know, you have 4K video that comes out of it, and the results are just stunning. You know, when you're looking through the goggles, and also, you know, when you play it back. I hope I've given you enough information about what this series of videos is going to be about. This is only my second FPV scale RC Warbird build. It's actually my only second FPV build. I'm sure I have forgotten several things on what I've done on the first build. So if I've missed anything, or if you have any questions while we go through this process, please comment, post, ask me questions. I'll try to address them in the next videos as I go through the build, or I'll, you know, try to respond to your comments. I don't want to leave anything out. If I make any mistakes, I'll make certain to include them because we all do make mistakes. So I appreciate you watching and following, and please consider subscribing. Thank you. And welcome to the second video in the tutorial of the putting FPV in the Eflite Carbon Z T28 Trojan. In this video, what I would like to do is go over quickly go over as quickly as I can go over the Speedybee boards, and then put it together. Let's download the Inav Configurator, connect the flight controller to the computer. Let's flash the latest firmware to the flight controller, and calibrate the accelerometer. It's not hard to do. The video, I'll try to be as in depth as I can with it. Doing it in the video will probably be kind of dry and even kind of slow, but when you do it yourself, it's actually kind of quick. So but I'll try to be slow, not as dry, but let's get started. When you get your Speedybee flight controller, it does come with a really nice quick start guide, and I'll open it up here. I did quickly show you this in the last video. I am going to quickly just show you this again. This it is a long format. You can you study it. It shows you how everything connects. Digital, analog. There is a more detailed manual on the Speedybee website. I will have links in the description, but we'll go through this quickly, through the video, so you can see how it connects. Here's the digital copy of the Speedybee Wing app instruction manual. You can see it a little better. This is something that I would say that you should probably, as you're building your own, maybe have it open on your own computer or phone or iPad or however you view your PDFs. Have it open in front of you so you can see it better than the paper copy. It's kind of small, but you can see the board specifications a lot better. And here you can see where they have the connectors here, where you can just connect them and not actually have to solder them. We are going to be using the DJI Air Unit and the GPS. We're not doing any of the analog stuff. We're not using an airspeed sensors. Here's where the S-Bus connector was. We're not doing that. Here, they say ELRS or crossfire receivers. We are going to be using Spectrum. So I wish they would have a Spectrum /ELRS /crossfire, but they do not. This other image right here is if you decide to do a solder instead of using the connectors. On my last build that I did, I actually did solder. In my head, I was like, oh, I don't want to be pulling in and out of the connectors, and maybe solder's gonna be better. I was just a little paranoid. But you can go through here and read more about it. We have settings. But we're gonna go through all of these. Let's quickly go over the Speedybee flight controller boards. The first board is the power distribution board. It's on the bottom. Right here in this section here is the VTX video transmitter, BEC. It's set at 9 volts on this jumper right here. That is fine for the DJI Air Unit. Right here is the the BEC for the flight controller. Right here is the BEC for the servos. The default setting is for 5 volt. You can use solder to change the jumper settings for 6 volt or for 7.2 volt. The pads right here is for the ESC and battery leads for the negative, and for the ESC and battery leads for the positive right here. This middle board right here is the actual flight controller. This right here is where you put the micro SD card, the black box where it records all the data. You can solder for the, and this section right here will be for the digital VTX or video transmitter. This middle section right here is where you could solder the GPS, or right here would be for the analog. Right here would be if you have anything for telemetry. If you have like a digital airspeed, sensor or analog. Right here is for S-Bus. I guess like if you for S-Bus receivers, S1, S2 is going to be for your motors. We only have one motor, so we'll be connecting, that here. And S3 all the way to S11 is going to be for your servos. Right here is going to be the connection for ELRS, Crossfire. But in our case, it's going to be where we connect our Spectrum receiver. But what's nice about the Speedybee flight controller is we do not have to solder here. We can if we want. The only thing that we are going to have to solder is the DuPont connectors in this area here. Let's flip this over. And what they do is they provide us the JST connectors. And what's nice, and I'll show you here, is in the package they give us all kinds of nice cables that that we can use to connect. So we have the option to solder or not to solder on these connections right here, but we do have to connect or solder these connections here. So there is some minor soldering. It'd be nice if we didn't have to, but we do. So let's move on to the next board, which will be the top board. And this is the wireless board, and the wireless is a Wi-Fi connection or a Bluetooth connection. It goes on top, and what's nice is that you can connect to the flight controller using the Speedybee app from your phone, whether it's an iPhone, an Android phone, or an iPad, or some type of tablet. You cannot do firmware updates wirelessly. You do have to connect it to your computer. These connectors right here are for LEDs. I'm not connecting any LEDs to this build, but that's what these connectors are for. This little board right here is the USB Type-C board. This is how we connect it to the computer, how we connect it to iNav. You also could connect this to the ArduPilot. So this is going to be an iNav build. It has a buzzer. This is a switch right here for the buzzer, on-off switch. This is the boot button. This is the flight controller. This is like a little LED status light. And this is where how it connects to the flight controller. Connects here with a cable. And if I can get it out of here. This is the cable that that they provide. that connects everything. So let's go ahead and put the board together, and we will do a firmware update and connect it to Inav. Now that we have the Speedybee flight controller put together, we need to upload the latest firmware onto it. To do that, we need to download the latest Inav Configurator. In the description, in the video description, I'll have all the related links that you're going to need. So that'll take you right there. The latest stable version of Inav today is Inav 7. And when you go to get the latest version of Inav, you will know what version is the latest stable release, because they notate it here. You can see where it says the latest. So what we're going to do is we're going to go grab the latest version of Inav Configurator. We're going to scroll down here. They're going to tell you a lot about, when you start, you can go and read all about the latest cool things that this version's doing, but we'll scroll back up here to the top because we're not going to do that here. So what we want here, you can see I have it highlighted here. Inav Configurator 7, so it says upgrading. So download and install the new Inav 7. So you can just left click here, but I'm not gonna do that. I'm gonna right click and say open link in new tab, just in case I need to come back over here. So I'm gonna come over here to the new tab, and right here it jumps right up to the top here. It says Inav Configurator 7.1.0 release candidate 1 pre-release. Again, I don't ever recommend using a pre-release of anything. I'm not a beta tester. I don't recommend any of you to be beta testers unless you are brave and you want to risk losing your plane. I mean, Inav's great, but I'm not that familiar with it that I trust losing, my stuff. So let's continue scrolling down here until we find, here we go, Inav Configurator 7.0.1, latest. This is the latest version. So you see here it says this version of Inav Configurator is intended to be used only with Inav firmware 7.0 Ferocious Falcon. Okay, so we're going to scroll down here until we get to where it says assets. So whether you have a Mac or a Windows operating system or even Linux, currently I'm using a Mac OS. So what I will do is you can either use the DMG file or the zip file to download. If you're using a Windows operating system, you can download the EXE for the 64-bit operating system, or you can download the zip file. It's your choice. If you have an older 32-bit operating system for Windows, you'll use Win32. I think the majority of people today are probably safe to use the 64. If you're unsure, use the Win32. And you'll be fine. If you are a Linux user, I can't help you. I don't use Linux, but if you're a Linux user, you know what to do, and you probably shouldn't be watching my videos because you are golden. But for Mac users, I'm just going to use the DMG, and I'm going to grab it, and it's downloading. So I'm going to let it download. I'm going to go ahead and install it. I'm assuming that if you have a computer, you know how to install your own software. So once it's installed, open up the Inav configurator, and we'll go from there. To connect the Speedybee flight controller to the computer, you're going to use a USB Type-C board, expansion board right here, and you're going to use a USB Type-C cable. It does not come with with one, so if you don't have one, you'll need to purchase one. But most people have one. If not, you need to find one on Amazon. But you'll connect it here like this, and with Inav Configurator already opened, here you go. It's booting up, and then your indicator lights will start blinking as it boots up. So now we can begin the firmware upgrade process. Okay, one thing that's important to note that I have found is to always have the Inav configurator open before you plug your flight controller in. So now that we have our Speedybee flight controller plugged in, we have Inav open. Let's do a firmware update. Also, I would like to say, I was just joking about any Linux users that may be watching my video. I don't want to alienate you guys. I am an IT guy, and I love and respect y'all. I don't mess around with Linux. I did a long time ago, but I don't anymore. Before we get going, I am on a Mac, but right here, this is this should automatically populate, through your USB. If so when you plug your flight controller, whether it's a Speedybee, a Maytech, or anything else, it should automatically detect what it is that you're connecting to through your USB device. If not, you should get some type of connection or error here, or somewhere else we're about to go here. You may have to do some troubleshooting, but that should be taken in on another video somewhere. That we don't have time to cover here. But from right here, since we have Inav 6 that is preloaded on the Speedybee, and this is the Inav Configurator 7.0.1, which is right here. we can't do anything with the flight controller yet in iNav. So the next thing that we need to do is to upload the firmware. Over here on the left side of the iNav configurator, we're going to come over here to where it says firmware flasher. And if you have the the connection over here, if it detects your USB connection, fine, it'll automatically or should automatically detect your Speedybee or whatever flight controller that you have. If it doesn't, you can click this button here, auto select target, and it'll find it. If we click this pull down menu right here, you can look and see all of the different flight controllers that iNav is compatible with. But we're going to be doing the Speedybee F405 wing, and you can see that it, as soon as we clicked on the firmware flasher, it found it. The next step is choose a firmware version for the Speedybee, and we are going to be doing the 7.0, and we are going to do a full chip erase. And you can see here the warning here is please do not try to flash a non-iNav hardware with this firmware flasher, and we're not, because Speedybee is the F405 wing is compatible with iNav. And we have two options here. We can load the firmware from online, or we can load the firmware local. So I do not have a local copy on this computer, so we're going to say load firmware online. And let's wait. Okay, and it takes us to the web page. It takes us, to the, we can read all about it, but as you see here, when it brought us here, this button right here popped up and it says flash firmware. So we are going to flash the firmware. As you see, the progress bar here says it's erasing. So what it's doing right now, it is erasing the flash memory on the what's currently on the Speedybee flight controller. Now it's flashing it with the latest version. It's also important to note that if something happens during the upgrade process, it says right here, recovery lost communication. Follow these steps right here. All right, it says programming successful. It is done. We are finished. Now that the flight controller has been upgraded, now we can get into it and start looking at it. So the next thing to do is to come up here to the little button up here that says connect in the top right hand corner of the iNav configurator, and let's click connect. All right, the first thing that happened is a little box here that says default values. iNav configurator would like to know what kind of UAV you are configuring using an airplane with a tail. And so let's choose that. All right, saving default settings. Now everything that we do in iNav configurator, anytime we do anything, we're always going to need to do a save and reboot. Anytime we move between screens, we do a save and reboot. And you can see right here, that's what it's doing right now. We made a change, and it asks us first thing, what kind of device do you have? And then it's like, okay, save and reboot. So all right, here we are. I'm not showing you on the other screen yet, but I'm picking up the Speedybee and has the accelerometer on it, and you can see that I'm moving it around. So we're getting ready to do a calibration on it here in just a second, but you can see that it is working. All right, so we will do a calibration on it. But this is the Inav configurator. So right here it says the Inav configurator 7.0.1 and the flight controller software is 7.0. And it recognizes it as a Speedybee F405 wing. All right, so everything is looking great so far. Well, the last thing we're going to do in this video is we're going to calibrate the accelerometer for the flight controller. And how we do that is right here on the Inav configurator. Is on the left-hand side is a little tab there that says calibration. So we're going to click on that calibration tab, and it's really easy to do. But this is why I hadn't soldered in the DuPont servo connectors yet. So after calibrate the flight controller, the next thing I'll do is I'll take the flight controller all apart, do all my soldering, and then put it back together. And then I'll start the next video in the series. So what we're going to do is we're going to get out of the way here because we want to be able to have a flat surface. So let's calibrate the accelerometer. So we want flat. Calibrate. All right, place the flight controller in position shown in image, then press calibrate button again. Repeat for each of 6 positions. Keep it stable during calibration. Okay. All right, so I'm going to place it flat. So calibrate. All right, let's put it on its side. Make sure it's flat. Calibrate. Okay. Make sure it's flat. Calibrate. Now, let's put it on this side right here. Make sure it's flat. Calibrate. Okay. Now, because I have a USB extender here, I'm going to put it on the edge of the table. So that's flat that way. Calibrate. Now, see if I had everything on here. Put it here, flat on the table. Calibrate. Accelerometer calibration finished. Check if values have been saved. Okay. Everything checks. But before we do anything else, we need to do a save and reboot. All right, device rebooting. All right, so let's come over here to setup. All right. There it is. The accelerometer has been calibrated. And now we can take the flight control apart and do what soldering needs to be done. And we can start configuring, and things should start speeding up from here. Also note that we shouldn't have to calibrate the flight controller again. The only other time on my last build that I've had to recalibrate, it was whenever I upgraded from version 6 to version 7. But other than that, I've never had to touch it again after doing it the first time. I appreciate you getting through the whole video with me. one of the things that I didn't mention at the start was, I didn't solder the DuPont servo connectors, on the middle board, the flight controller board. I didn't do that because I wanted to calibrate the accelerometer on the flight controller first. Now that we've gone through putting it all together, powering it up through the computer, flashing it with the latest version of Inav, we know that it works. We're not going to have to send it back because there would be that question if I went ahead and soldered it first and had it all done and then put it together, powered it up, and it wasn't working. Was it my fault or was it fried before? So doing it that way, now we know that the board is fine, and so now if I solder it and fry it, we know it's my fault and not it didn't come that way to me. So it's kind of I would recommend when you get your flight controller that you do that as well. Make certain that the board is fine before you do anything to it. So it can kind of give you a peace of mind. So after now that we've done this video here, I'm gonna go and I'll start putting it all together for the for the next video. So thank you for following me on this one, and I'll drop the third one soon. Again, please consider subscribing, and I'll see you soon. Hey, welcome back to the third video of putting FPV in a Carbon Z T28 Trojan. Trying to get the videos, keep them a little bit shorter. And this one we're gonna just set up a basic model on your transmitter. The in between the last video and this video, I went ahead and soldered up the flight controller. I'm not the best person to solder these things up. I'm getting better as I go along. I had to use my wife's. She had the silicone, I think cookie sheet or something. I don't know what it was, but that kind of helped me, keep the flight controller from skidding along my table as I'm soldering, because I'm using some EC5 battery. These are really thick 10 gauge wires trying to solder this thing down there. It's really thick and it's taken me a long time to do it. So if y'all have any better ideas, let me know, because these things are, the EC5 cables are pretty thick, and there's not really a lot of room on these things on the power distribution boards. But one thing I did point out is, being that the Carbon Z T28 is a big plane, and it has these retracts on the servo BECs. I did put the jumper at 6 volts, so that way we get enough juice coming through in this. So basically, what this video is going to cover is just a basic model setup on your transmitter, so that way we can bind the Spectrum receiver on the flight controller. We're going to go ahead and just do a real quick setup on the GPS. We'll plug the DJI O3 Air Unit in. Just going to quickly just go over that stuff on the Inav Configurator. Really what I want to do is get the basic stuff on the controller, so that way we can get this into the plane, and then once we have the stuff in the plane, then we can start doing some more of the advanced settings that we need to do to get this thing in the air. So let's go ahead and get to it. All right, one of the first things that we're going to need to do is go ahead and create a model on the transmitter. So let's just go ahead and start that. We're just going to need to just do a basic acro model. And I have an IX14 Spectrum, so just going to add a new model, do a default airplane, macro, and okay. All right, now that we have that started and done, we can go ahead and let's get to the flight controller and into iNav. In the last video, we were going over the components of the Speedybee flight controller, and you know, now we went ahead and soldered it up. You know, I'm not the best at soldering, but you know, I've got it done. And you know, the things that we have to solder is, you know, what I have here is I soldered the battery and the ESC leads on here to make it, you know, easier to connect and disconnect. And then we soldered the DuPont servo connectors, and we're gonna connect them here in just a second here, but how we're gonna connect the receiver. This is where you would connect if you have ELRS, Crossfire, and in our case, we're going to connect the Spectrum receiver. And I'm going to show you how we will do that. If you are using S-Bus, you would connect it right here, but we're not using S-Bus. So what we're going to do is we're going to connect to the GPS, and I'll show you how to turn it on with a software switch in iNav. We're going to connect the DJI O3 Air Unit, and I'll show you how to turn it on. And we're also going to connect the Spectrum receiver, and we're going to bind it to iNav and show you the CLI or command line commands that you're going to have to put in iNav to get it to work correctly, to be able to use it. And it's not hard. You know, get it in there, and then everything will be good to go. So what we have to do, because of the type of, you know, receiver we're using, we have to use an adapter. And this was the, you know, what I was showing in the first video, is you have to get this adapter cable right here. You have to order the for the SRXL2. You know, it comes with you know, a special cable that has, you know, these JST ends right here, but you need a DuPont end, and so that way, you know, that you can use it. So then I use a, you know, an adapter cable, you know, an extension cable, and then I use a single DuPont end, because right here there's it's a four pin connector. And so what you do is it's basically you pull this first wire in right here, your signal wire, and you skip it, and so we can connect them right here. So to make it simple, this is going to be a blank. There's nothing connecting to this wire right here, or to this pin right here. And hopefully I'll pull it here so you can see it. So we're going to go ahead and connect the receiver. And then we'll, on this fourth pin right here. So that's going to be the transmit and then the receive signal is blank. There's nothing connected to it right here. And then there you go. That's all you got to do to connect it. And then so the Spectrum receiver is connected. And then for the GPS, we're just going to connect them right up here. Make certain that the little pins line up. Make certain that it's in there good. And when you place it in the plane, this is up. And then we're going to connect the DJI Air Unit. It's right here. Now, when we connect this right now to iNav, we're going to connect to the computer through the USB Type-C port, and it's going to have power, but it's not going to power the Air Unit. What we'll do is we'll connect the battery and all up to it. So we'll do that as well, so we can see that it's working. Let's go ahead and connect the USB-C port to the flight controller. Okay, we have lights, and we'll go ahead and connect to iNav. Okay, right here in the right-hand side of iNav, you can see that everything is green. This is your pre-arming checks. Everything's good. One thing that you want to look for is to see that the GPS is green or blue, whatever the color is supposed to be, but right now we have nothing because we haven't enabled it. So we want to go ahead and turn that on. And you can see right here the GPS, the lights are blinking, so we know that's connected. So let's go ahead and start configuring iNav. So in iNav, you can a lot of it you can just leave default, but we're gonna touch the stuff that that we need to get our plane flying and flying well. So what we want to do is come in here to this configuration tab right here, and here in the first little section here, the sensors and buses, and it tells it already detects what our accelerometer is. We're not going to mess with the magnometer. We have a barometer on the flight controller. We don't have a pitot tube, rangefinder, optic flow. We're not going to mess with any of this. The voltage and current sensors, we'll leave everything here to the default. What we're going to want to do is come right over here into the other features right here, and we want to turn the GPS for navigation and telemetry on. And we also we want to leave the black box flight data recorder. This is in the flight controller. Right here in this middle board right here, there's a place for a micro SD card, and that's where you want to put your black box to record your data. So we want to leave that enabled. You also need to, it's very important that you enable motor and server output. If you do not, then nothing will work. So we want to enable this. Obviously we're doing FPV, so you want to enable the OSD. It is enabled by default. Permanently enable air mode, we want to leave that enabled. We are not flying a wing. We're flying a plane that takes off, lands on landing gear, so we're not throwing it up in the air, so we're not touching this. I'm not real familiar with this, to be honest with you, the throttle voltage compensation. So if any of you are familiar with that, and if you want to school me on this, whether we turn this on or not, please school me. But the continuously trim servos on fixed wing, I leave this enabled. I turn it on. I found that you know, on my other T28 Warbird that I set up, you know, this continuously trims the plane while I'm flying, and then it flies great. So we're going to turn this on. Okay, so in the last video, I shared with you that anytime that you make any changes before you leave the screen that you're on, you always need to do a save and reboot. So we're going to do that now. Okay, so what we wanted to do is to see if the GPS is detected, and it is. I'm going to come back up here to the setup, into the pre-arming checks. It still shows green. The GPS icon right here is showing blue, detects it. Now, whenever you place the GPS in the plane, you want it to be clear of all electronics, as clear as you can get it away from the motor, the ESC. You know, if you needed to use longer cables to get it away, then do that. But this is, you know, the direction you can see right here. This needs to be pointed up. Now, unfortunately, where I'm doing this right now, I'm in my workshop, and it's all metal. If it wasn't for that, you would be seeing satellites being detected, and when we get further along, when I take everything outside, you'll see the satellites being populated. But what we have here is 0, and that's because of where we are. But let's go ahead and configure the GPS. It's rather simple. So we're going to come over here to this tab right here. That's GPS over here on the left. So let's go ahead and click that. You know, by default, it's U-blocks. If you click this pull down, this is what we're going to keep it at. This U-blocks. The ground assistance type, I pull this down and use North America, because that's where I am. And then, you know, we can come in here and mess with that. I've never messed with that, but you can. You got to do. If we were pulling up satellites, you know, if it went for the workshop, it would start. You know, you could see, you know, where we were. So let's go ahead and do another save and reboot. The next thing we're going to want to do is let's go ahead and make this. Let's get the DJI Air Unit where it's alive. So we're going to come here to the tab that says ports. And this is UART. And even though we have a DJI FPV, you know, unit, is we use the MSP display port. Okay, so that's all we're going to do to make certain that the Air Unit is going to work. So before we leave here, we're going to do another save and reboot. Now, since we have the GPS configured, let's go ahead and set the fail-safe up. Now, the fail-safe is, you know, like what happens if you, you know, your transmitter loses connection to the receiver. And so we're going to go ahead and click on the fail-safe tab right here. And you know, these are your options. You're going to drop it, you're going to land it, you're going to return to home, or you're going to do nothing. Well, not a drone. I'm not real familiar if these things can land. I don't think it can. You know, maybe it can, but what we want to do is we want our planes to return to home. So we're going to choose return to home. and then we'll do a save and reboot. And that's all we need to do. And we'll go through just, you know, a little bit. We'll go through how we can set up return to home on switches. Now, it's, you know, one of the things that I think I failed to mention earlier is, you know, you're going to need on your transmitter, you're going to need something more than, you know, a 6 or 8 channel transmitter. You know, I currently use a Spectrum IX14. You know, in the beginning I was using a Spectrum NX10, and you know, I was able to use it, but there were some features that you know, that I couldn't use in iNav. So you will need something, you know, with more channels. And this is why, you know, a lot of people say you need to use, you know, something like a Radio Master, an FR Sky, you know, something with more channels. You know, I recommend you don't use anything less. If you're going to use Spectrum, I suggest you don't use anything less than an NX10, but something with an IX14 or better, or, you know, use something like a Radio Master TX16S, or, you know, an FR Sky. Use something that gives you substantially more channels. All right, so the next thing we're going to want to do is we're going to want to let's go ahead and bind our receiver, and let's get that set up. But to do that, we're going to need to plug the battery in. All right, so let's go ahead and do another save and reboot, because I don't remember if I did that. And then we'll plug our battery in and go from there. Okay, now we're going to plug in a battery. I'm going to use a 6S HRB 5000. This is going to be the battery that I use to fly the Carbon ZT-28. So now's a good time to test it and make sure we don't let out any smoke. I'm kidding, I've already tested it. All right, so there we go. Plug it in, and let's connect back to iNav. All right, so what we want to do is we want to come in here to this tab here to receiver. And this is the receiver tab. So since we are going to be using a Spectrum receiver, Spectrum does things a little differently. We need to change the channel mapping. So we're going to change it to right here, to this GR Spectrum and Grotner. And we're going to leave the serial right here. We're going to change this to SRXL2. And we can leave everything else default. And then we are going to just bind it like we do any other plane. So I'm going to push the bind button, and it's flashing, and I'm going to come to my transmitter and push bind.
Binding.
And it's binding.
DSMX 22 milliseconds. Telemetry.
There it is. Done. All right, but it's not really done. Okay. And we need to do a save and reboot. All right, so now there's going to be some configs we need to do some command line stuff in iNav. And now that it did a save and reboot, if you look now, the 4651T Spectrum receiver is actually a 20 channel receiver. It's a full telemetry, full range receiver. Now you see here, all the stuff shows up here. Okay, since we're using the Spectrum receiver, what we want to do is we want to set the range. And what I found is in the INAV documentation, they have some examples to use for spectrum, and I found that, you know, in my last build, using their examples was actually spot on. And so I'm going to use the same settings. And the settings was to go into the command line, and we're going to go here in just a second, and to use these parameters right here. And what we're going to do is we're going to put these parameters in here, and then when we put the flight controller on the plane and we connect everything up, we will, you know, we'll test out the control surfaces, and you know, and we see that we have full range of motion through the control surfaces, we'll know we're good. If we find that we don't have, you know, full motion, then, you know, what we'll do is we'll start adjusting, you know, the range. And you know, if we're not happy, we need to go back to the default. Then all we got to do is go in the command line and do an RX range reset, and we'll go back to what the defaults were. We can, you know, we can play again. But this is something that we found, you know, that people have been complaining about whenever they try setting, you know, setting up INAV with the flight controller using the spectrum receivers, and it has to do with, you know, not getting the full, you know, range, full resolution, you know, through their their channels. But this is really all we have to do. So what we'll do is come in here to the very bottom, and right here it says CLI, we're going to click that. And this is a good place to do if you ever have any problems, things aren't working. You can connect your computer to your flight controller, and one of the most handy things to do is to say, hey, I want to see what's going on. Show me a status. And so, you know, type status, hit enter, and this can tell you, you know, hey, this is what's going on with your flight controller. And here you go. It tells you a little bit about the system uptime, the current time. I don't have the battery connected. And, you know, earlier, you know, when I was going to bind the receiver to the transmitter, you know, I connected the battery. You don't actually have to do that. You know, there's enough power coming through the computer to power the receiver that, you know, you can bind it and play with it. In fact, if you see right here, I have power coming to the receiver, and I do not have a battery connected to it. So, you know, I don't want you to think that I was giving you misinformation. I just wanted, you know, to connect the battery to the flight controller, so you can see that there was no smoke coming out of it. But anyhow, so doing a status can kind of, you know, it can show you what's going on if you have any errors going on. If you look here, VTX, you know, not detected. Well, it needs the battery for that to show the air unit. But what we're going to do is let's go ahead and fix the spectrum. So we're going to come here. We're going to use these commands, and it's only going to use, you know, we'll need to do it for these four right here. So we'll just do a copy and paste. And we'll do a copy and right click, paste, and hit enter. All right, and then I'm going to come and just grab the second one. Oops, that was great. Here, I'll just grab the third one and change that to a 1. Copy, paste, 1, enter. That's a 2, enter. And then I can, you know, just really, it's all I need to do is just change that channel there. And let's 3, enter. And then when you're done, you always need to do a save, enter. Then it's going to do a reboot.
Receiver fast booted.
Okay, and we're back in. Okay. Okay.
Timer start. Timer stop.
All right. So at this point, we're actually ready to start putting this thing in the airplane. We're going to start connecting everything up to the flight controller. We need to place it in there, and we have some more advanced configuration. You know, we want to, configure the switches, configure arming, configure return to home, configure the loiter. The loader mode. We want to configure, the, all the other stuff that goes along with it. So we'll do this in the next videos. I wanted to pull this the flight controller out and take it outside so that you can see that the GPS is actually working. So we'll come out here and click connect, and we see that the GPS icon is good. See, navigation is safe. That means it's locked on to satellites. We can see that also that it's detecting, what the voltage is on my battery. We're going to come down here. I'm not going to go all the way down because then it's going to give you my exact location. But right here, satellites 11. It's picked up 11 satellites. So GPS is working. And we need the GPS to be working because of the DJI O3 Air Unit. It stays in low powered mode. And so whenever the way that DJI has the Air Unit set up, it needs to be armed. And so having the satellite lock, once it gets satellite lock, we can arm it to the flight controller, and then it goes into full power. And we're good. And through the satellites, we're able to get, on the on-screen display of the goggles, we're able to get the, our headings, our altitude, or measure ground speed from the GPS. We get a lot of cool things that the GPS offers us. Like the return to home. We can do the loiter. It's pretty handy. So, but yeah, I just wanted to show you this, that the GPS is working, and it's pretty slick. So, all right, there we go. I appreciate you getting through this one with me for a third time. It's a lot of you go through the Inav Configurator and you see all of these settings, and they can be really intimidating. A lot of you can leave, default. There are some tweaks that we're going to do as we get through here. You saw when we went through the command line interface, or the CLI, it can be kind of intimidating. And you saw that we did some basic configs in there for the Spectrum receiver. We're not really going to know how it looks. Those are what I used in my last build for my FMS T28, and it was perfect. It was spot on. And I feel that it's going to be the same for this one right here. And if it's not, we'll know whenever we plug it all in and we go to test it. If it's not, we will we'll reset it, and we'll troubleshoot it, and we'll go through it. But I'm fairly confident that that's what those are gonna be the right settings for it. This is at this point, these last three videos, we've gone over the flight controller. We haven't really touched the plane. Going forward, we're going to be diving into the plane. We'll have everything in the plane. I have hopefully we're not going to have any issues with the stock ESC that's in this T28. I have read where at least one or two issues where some people have had some issues with the ESC that's come with the Carbon CT28 working with Inav, and I don't know if that's standard or if that's just maybe something in how they configured it. We're going to find out, if that's true. and I come into it and I have issues with the, with the ESC that's in the plane, that I'm going to have to pause and, order something else, and, we'll go from there. But so in the next videos, we will be in the plane, setting everything up. It's going to get less dry and more interesting. So again, I appreciate you following along with me so far. Please consider subscribing, and we'll see you in the next video. Thank you. Hey, welcome back. We're here again. This video was pretty challenging for me. There was a part of me was like, I don't think I'm going to get this one done. The challenge was the retracts. This is a big plane. The retracts require a lot of power. I was thinking, when I was putting this plane together, I was thinking, well, I can control the voltage on the BEC. So in my mind, I was like, well, let's put 6 volts. The servos are rated as 6 volts, and so I can make certain there's enough, power going through. There shouldn't be a problem. That wasn't the best idea. I learned that wasn't very smart. When you for the servos, when you give them more voltage, they get they move faster, they get more torque. I ended up burning out a servo. The nose, the servo used for the nose steering, I ended up burning that out. But the challenge was that the retracts, whenever when you get 3 retracts, so when you flip them on, it has like a burst of power that it needs, and the Speedybee isn't giving it. It's not allowing that much power to go through. I tried all kinds of things. I ended up trying to use another UBEC, UBEC, with another power source, trying to supply just power for the retracts. I could never even get that to work right. I ended up burning one of those out. The solution that I came up with was to put to split the retracts to 2 different switches. So it's not ideal. Maybe another flight controller, maybe one of the higher end Maytech flight controllers can give you more power at that initial whenever you flip the switch for the flight for the retracts. But basically, it's a flip one switch, send 2 retracts down, and then flip the other one for that 3rd retract. It works. The problem is, if you do this, you're going to have to remember to do it each time whenever you take off, and also when you land, you can remember that your retracts are 2 switches. Luckily with the IX14, I can type in the prompt in there, so I can tell it to say, when I flip a switch, say, hey, don't forget the 2nd switch retract, vice versa whenever I'm landing. So that being said, I did go back to the BEC voltage jumper and remove the 6 volt, put it back at 5 volt. That's plenty. You don't need to, for this build, for this plane, 5 volt is all you need. So yeah. So with this video, it's not going to be short. I wanted to be very thorough and very detailed on everything that we're going through on this. We're going to finish setting up the model on the transmitter. On what you need to do here, we put the flight controller in the plane. I show you how to hook it up. I go through how to set up the channel servos in Inav, on how to get them working, and I also go through calibrating the ESC and give you a demonstration on how all that works. Basically, at the end of this video, we've got a few tweaks we still got to do, but we are at the point where this plane can be taken out and do line of sight flying. And you know, outside of that, the next step, except for a few minor tweaks that we need to do, we're ready to start putting the FPV gear in pretty soon. So let's get going. Before I take out the Spectrum AR637T receiver, in the first video I showed you the rat's nest of wires that how it comes from the factory. Since then, I've ordered some multiplex connectors. I actually got them from a guy on the RC Group forums. He makes these for individuals who order them, but you can also get these from other companies. But these are quick connectors, so that way you can just connect them and disconnect them easily for each wing. This way it's not going to be a big mess. But I just wanted to show you, that these type of connectors are available. It's kind of long. I'll do something hopefully to have some better wire management. But there's a lot of room inside the plane here to do something with them. But I just kind of want to show you what I have here. I've already connected them, to the Spectrum receiver here, and tested them to make certain they're working before I take this receiver out. So now what I'm going to do is to take this Spectrum receiver out. Since we're not going to be using it, I'll take it out and go ahead and start setting it up to put the Speedybee flight controller in here and get everything connected, and we'll start programming this plane for the flight controller. Okay, we got the Speedybee flight controller in the fuselage now. I know right now it's a big mess. We've got the quick connect cables in here, and they're long, but they're going to make it easy whenever we carry the plane out to the field, and we're able to just snap the cables in and not have to worry about fishing the cables in and keep connecting them to the flight controller each time. What I did is I removed the receiver, the Spectrum receiver that came with the plane. It was right here. It was a Spectrum AR637TA. I pulled it out, and what I did is I put a piece of plywood that I got from a spare piece of scrap that I had from Hobby Lobby, that I cut out and put right here, and mounted here with double stick foam tape. You can see it's not going anywhere. Went ahead and mounted my GPS right here. It's also mounted with double stick tape. It's not going anywhere. Remember, you want this little piece of tin right here, you want it to be facing up towards the sky. And this right here is the USB Type-C connector. This is how we'll connect it back to the laptop so that we can get back into Inav Configurator to get to it. Here in just a second, we're going to connect all these cables. Now, I was doing some testing before I was making this video, and was struggling with getting the retracts working right. So we're going to go through that, but we're going to show you how this stuff's going to connect before I connect these wires. But in these header pins here, this right here, just to be clear, because once you start connecting this stuff, it's going to be hard to see. But this pin right here is for the S-bus if you're connecting an S-bus receiver, and we are not. We're going to be connecting the Spectrum SRXL2 receiver, which is going to be connecting to these pins, these 4 pins right up here. So where we're going to start is we're going to start with the throttle, and we're going to connect it right here. And then we're going to, so that'll be the S1, and we're going to skip the S2, which is another motor here. So we're not going to put anything right here. So what we're going to do next is we're going to start on the S3, which is going to be for the pitch, it'll be the elevator. So that'll be here. And then the next one is going to be the aileron. And since Spectrum put the ailerons on a Y connector, we're going to leave it on a Y connector. I had originally set it up so that way we could put each aileron on its own pins, but because I had to play games with the retracts because they require so much initial voltage going out, and I'll explain that. I'm going to leave them on the retract. So we're going to do nothing here. That's S bus. This one's going to be where you hook your throttle for your motor. This will be empty because that's for another motor, which will be empty. So this pin right here is going to be for your elevator aileron. We're going to leave this one empty, and then this one is going to be for your rudder. This one's going to be retract, and we're going to have a second one for a retract, which we're going to have to play games. But this one's going to be for your first retract. This is going to be for your flaps. This is going to be for your pan. And we're not going to hook it up in this video, but this one will be for your pan. This one will be for your tilt, and we're not going to hook it up in this video. And this last one is going to be for your second retract, your second gear, because we're going to have to put the gears on two switches. That's not going to be ideal, but this is a limitation of the BEC of the onboard on the Speedybee, on this flight controller. I was struggling with getting this to work right. I didn't have to do this on my FMS T28, but this is a larger bird, and I had burned up a servo, a smaller servo, trying to get these to work right, but it was just it was very challenging, and this is the solution that I came up with. So I'm going to go through this quickly again because it's going to be a big mess of wires once I show you, once this is connected. So these pins right here, S-bus, unless you're doing S-bus, you're not going to connect anything to here. So again, these 4 pins right here up at the top, this is where you're going to be connecting your, for our purposes, it's going to be the Spectrum SR-XL2, or it would be for your ELRS or your Crossfire. So this pin right here is going to be your throttle, or for your ESC. This one's going to be empty. This pin right here is going to be for your elevator. For us, since we're using Spectrum, it's going to be aileron. This is going to be empty because aileron's going to be in a Y connector. And this one right here is going to be rudder, gear, or retract, flaps, pan, tilt, second gear, retract. And on that empty pin that we're going to put on the aileron, I'm actually going to put a capacitor on there, and I'll show you that. That's going to be, for me, kind of a peace of mind. It's kind of like you put on there for, to have extra power on there to help prevent brownouts. I don't know if that actually works. I think it does, but I'll show you that as well. All right, so I'm going to go ahead and connect all these up, and I'll show you how messy that is, and we'll try to get some wire management here as well. I do want to point out, before you connect your throttle, you want to pull, since the ESC has a BEC on it, you want to pull out this the red power cable so that it's not competing with the BEC on the flight controller. So pull it out and keep it. I put this single DuPont on it so that it's not, so it doesn't short something out, but so that way you're just getting the signal and the ground on it, and then put it on there. Okay. here's everything all wired up. Now, it's messy right now. You know, I just threw it in here. I'll try to get better cleanup, but it is a lot of wiring, and it is going to be messy. Here's the capacitor that I was talking about, this is actually what I use. It's a Hobby Eagle. I get it from Motion RC. It's a 3300 UF capacitor. I think they're a couple bucks, $2-3. I'll put a link in the description on, you know, where I get it. But I figure, you know, a little bit of protection is helpful, because, you know, there's a lot riding on this thing. But this is, everything's going to be filled up on the flight controller, and you know, we'll get to in the next video. We'll get to when we plug in the pan and tilt gimbal when we plug them into these pin headers over here. Yeah, all right. So also we're going to get to, if you notice, you see right here, you have this arrow where it's pointing towards the back of the plane. So essentially what I've done is I have mounted it backwards. And I had to, because the lead cables that I've soldered onto the flight controller for, you know, to connect the ESC, and also to be able to plug the battery in. You know, I didn't want to have to, you know, reach them over. So what we'll do is, that's actually a software fix where we can change the angle of the flight controller. You know, the flight controller doesn't have to be that way. I mean, we can, through the software, we can tell it, you know, which direction. It could even be on its side. So I'll show you how to fix that as well. All right. So yeah, it's messy, and it's going to get messier. So, all right. So here we go. We've got everything connected. And so the first thing I want to do before we start anything is, let's go ahead and set the alignment of the flight controller. You know, I don't have the camera on the plane, but what I'm doing is I'm going to pick the plane up from the horizontal stabilizer, and so I'm picking it up in the air. But as you can see on the screen, it's showing that I'm not, so that it's the opposite direction. So what we need to do is set the alignment, and this is really simple. You know, we're going to come down here to the left side of the Inav Configurator, go to the alignment tool, and we're going to come right here. You can also do this in the command line with CLI, but we have some options here. We can change the roll, the pitch, or the yaw. Well, you know, this the only thing that I did is I you know, flipped it around 180 degrees, you know, so that way I could connect the ESC and the battery easier. So, you know, so all I did was I'm affecting the yaw. So all you got to do is come right here, and I'm just going to type 180, hit enter, and or, you know, I can just change, you know, the slider right here, and you can see, you know, everything's moving with it. But I'm just going to come right back here, type 180, because I just did a 180 degree flip on the yaw, hit enter, and then again I have to hit save and reboot. One thing I want to point out is that, you know, I said in the very first video that the GPS that I you know, that I chose for this build has a compass on board, and you know, whenever I was enabling everything, you know, with the GPS, I didn't, you know, turn on the magnometer, and it's not really needed. I know that in drones, people turn I think it's needed, you know, the compass, the magnometer all is needed in that, and I think with Inav 7 and maybe in the newer 7.1 when it's released, and it's probably going to be released soon. I think for fixed wing, it's going to be usable. Maybe I'll come back and revisit it, but that's why I didn't turn it on. It's from what I understand, it's not really needed or usable, or I don't know if I've read or heard that it maybe causes issues, but maybe not with Inav 7. But I don't really need it, from what I'm doing, so I didn't turn it on. So I'm not really messing with it or enabling it. But so anyhow, what we're doing here is we are fixing the alignment of the flight controller since I put it backwards in the plane. So I now need to click save and reboot. This is my transmitter fussing at me. Okay, so it's rebooted, and I'm going to come up here to setup so I can see a picture of the plane. It says it's crooked a little bit, and it is. So I'm going to adjust it. Yeah, look there. And now if I pick up the tail of the airplane, I'm going to pick it up so that the nose points down. And there it is. Yes, it is correct. And if I turn the right wing like I'm going to the right, it is. Left, if I pick the front of the plane up, it should go up. Yep. So, yes, it is correct. So, that is how you change the orientation of the flight controller. That way, and that is important because it has the gyro, it has the accelerometer, it's got stabilization, and if it's not right, you can just stick it any old way. It even shows the picture here, the arrow, the orientation. Okay, so that's how you set the alignment if you need to put the flight controller in a different orientation in your plane. Okay, let's start configuring the servos, or the channels. So what we're going to do is we're going to come in here to the mixer. All right, by default, once we bound the receiver, in our case we bound the Spectrum 4651 receiver. By default, it gave us four servos, 1, 2, 3, 4, the pitch, roll, and yaw, and it set up the ailerons on each, basically on its own channel, or its own servo, and effectively we could say that it's its own channel. And right here, what I want to show is right here where it says output mapping. This is equivalent to when I was showing you the pins on that railing where everything was connecting. That first one that we skipped, that would be for the S bus. S1 was for the motor, or the ESC. S2 is for a second ESC, and we skipped it. S3 right here is going to be for the servo 1 is going to be for the elevator. The next one is going to be for the aileron. The next one is going to be for another aileron, but since the this model has a Y connector, we're going to leave it on the Y connector, so this is empty. And in its place, remember, I'm putting a that capacitor. And then right here, for S6, we're putting the rudder, and then S7, we're putting the first gear or retract, and then on this one, we're putting the flaps, and then the pan, and then the tilt, and then the second retract. And that's what this output mapping is. This is going to be physically how we've got everything connected to the Speedybee. So just when you look at this as, okay, this is the actual physical mapping of where we're plugging everything in. All right, so what we need to do is we need to add some new mixes into this. And this is actually very simple. It's not complicated, but we need to change some things here, or change something. And the first thing we need to change is, since we are keeping the ailerons on the Y connector, you see that says 1, 2, 3, 4. We need to tell it that they're not on separate pins. So all we got to do is, we're keeping them on pin 2. So all we got to do is change this right here, 3, to a 2. So I'm going to put a 2 here, and then I'm going to hit enter, and then I'm going to we're just going to keep moving. All right, so now it's going to bind these two together. All right, the next thing we'll do is, now I'm going to try to explain this in a way that how I understand it, so that maybe you can understand it the same way. You have your transmitter, and that you have your channels that you control servos with. And if you also have, like your transmitter has channels that that you assign to switches, but you can also, switches control servos, and so that's what these are doing. This right here controls servos, but you can also assign switches to do other things, but not to control servos. And that's what we can do when we are going to, when we can set things up for arming, and to set up, the loiter mode. You can set up, your buzzer, return to home, your auto tune, the trimming stuff, and that stuff's going to be set up in the modes tab right here. And we'll get to that, but if you find yourself working in here and you're like, okay, well, I need to assign these switches, you're not going to assign those switches in here. And so just kind of bear with me on this. So, but what we need to do is, we need to assign some more channels to correspond with these output mappings right here. So what I need to do is, I need to add the rest of the mixes, or the channels for the retracts, the flaps, the pan and tilt, and for the extra retract. So all we got to do, is real simple, is I'm going to add a new mixer rule, and this one right here is going to be for the first retract, and we're going to leave it at 5. And all we're going to do is, I'm going to say, click this pull down menu, and I'm going to scroll down, say RC channel 5, and then I'm going to add a new mixer rule, and it's going to say 6, and I'm going to click this pull down menu, and I'm going to come down here and say RC channel 6. Then I'm going to say add a new mixer rule. It's going to say 7. You get it by now, right? I'm going to come down here and choose RC channel 7, and then so this 5 right here, this one is going to be for my retract or gear 1, and you're going to get why I'm saying gear 1. And then this one right here is going to be for my flaps. This one right here is going to be for my pan. I'm going to add a new mixer rule, 8. I'll scroll down here to RC channel 8. I need to add one more, and this is going to be add mixer rule 9. This one I'm not going to say 9, because I'm actually using 9 somewhere else, or will be using 9 somewhere else. So I'm going to actually call this one RC channel 13, because I may later on, when I may come up with a better solution. But right now, for what I'm doing here, to make the retracts work on this flight controller, I'm having to split the retracts to 2 different switches. It's not ideal, but this is how I'm getting it to work on this the Speedybee flight controller. All right, so here we go. So now, before we can move on, we got to do a save and reboot. Okay, now that it's rebooted, everything is here. All right, now we need to go to the Outputs tab. So that's the next one right here to the left. So we click on that. Okay, so we will look at, we got the different ESC protocols. I'm not real familiar with these. I know that the people with the drones use like the D-Shot or the multi-shot, and I know that there was some compatibility issues with the last iNav version with the Speedybee. And I was messing with these on my last build, and it was kind of sporadic. So I just left it at standard, and standard worked fine. And then the silver refresh rate, I've had good luck with just going at 100 hertz, so we'll leave them at that. Looking at the only thing I want to point out here, the number of motor poles or number of magnets. In the manual for the on the Eflite Carbon Z T28 Trojan, it does specifically mention that there are 14 number of magnets, and it says to put this in here, so it's already there by default, so we're good. All right, so we will get into how to calibrate the ESC here in a little bit, so we're just going to skip past this right here. Okay, so when we added the extra in the mixer, it added all of that in here. All right, so with the in the manual, it says that we have to reverse the gear. And so that's going to relate to servo 5. I'm just going to tell you that I already know this. So we need to do a reverse. So that's here. And servo 9, it's already reversed for us. So if it's not, if you're doing the same build with me, just know that if you're having to split your retracts to 2 different switches, just know that they both need to be reversed. And then we'll get to that. So I'm going to do a save, and then I think what we need to do now, we'll go ahead and do a save and reboot. And then what we need to do now is we need to go ahead and move to the transmitter, and let's go ahead and get that set up, and then we will test it, and then make sure everything's working. We'll come back and calibrate the ESC, and then we should be good to go. In the last video, we were just really quickly, we set up the model, and that was so that we could bind the receiver. But we do need to do some more setup on the transmitter. The first thing that we need to do is we need to set the aircraft type up, and we need to do that so that way we can set up the flaps. So go to the model setup and go to the aircraft type. And what you want to do is you want to set up the wing type. And the wing type is one aileron and 1 flap. And that's also how the manual tells you to set it up. When you buy the plane, if you get the buy and the fly version, whatever, it says set up 1 aileron, 1 flap, and a normal tail. And that's all you have to do. Set it up that way, and that setting up that way will also in the menu options will give you the flap setup. So set it up that way, and you're good to go. Now I've already set it up in the transmitter, so I'm just gonna that way I can just quickly show you how I have it set up, and then you can either copy my settings or I have my own way that I like to use my switches. So set yours up according to how you like it, but this is just how I have mine set up. Okay, so the next thing, I'll quickly show you how I have my flaps set up, because it's real simple. You don't have to set up, some people when they're setting up iNav, I think they do their setup or mixes or something, they set it up in iNav itself. You don't have to do that. You can do it through your transmitter. All you have to do through iNav is to set it up in the mixer like I had showed you. You set up the mixer, the channel, so that way you can assign it the servo and the the channel, which we did. And then here we go. I'm going to go to the flap system, and I assign it to the switch. For me, I like to put my flaps on switch E, and then I set it up according to how the spectrum or the Eflite for this plane tells me to do it. So -100, elevator 0, position 0, or position 1 is 0, 10% elevator. Position 2 is 100% and 18% elevator, and speed is 2 seconds length. That's it. That's all you got to do. And you know, if you look here on the flap section, if I do the, and then I'll show you here in a little bit, whenever we connect it up, you'll see, whenever we test all the control surfaces, you'll see the, you'll see the elevator working. All right, so we'll get out of here. Okay, but let's come back here to the model setup and the channel assignment. Okay, so for the channel input, obviously, you can't really do anything for the, throttle elevator, aileron rotor. But this is how I assign my gears, or for the sliders. For 7 and 8, you see how I've got left slider, right slider. That's for my pan and tilt. Whenever it is not connected to the head tracker, I like to be able to, use the sliders to sit there and move the, the pan and tilt gimbal. I can just stand there, look at the plane, and I can move the, make it move in the cockpit. So I'll have assigned there, and then, so I can have them physically assigned. But what you do is, whenever you are, when you have the head tracker on, you assign it to the trainer port, and you flip a switch, and then then it works. But whenever it's not, whenever you don't have it in the student mode, you can control it with the sliders or whatever. All right, and then so then you see that I have channels 9, 10, 11, 12, and I don't have 14, but 9, 10, 11, 12. You see that I have them assigned to switches, but you didn't see me assign those into the mixes. And the reason why is because I have them assigned to do other functions, like the loiter, the return to home, the do the trim functions and all. And we'll get to those. Those get assigned in the modes function or modes tab in the Inav Configurator. And I may change the switch F, because I remember that that's actually the switch that I use for controlling my head tracker. But right now I've got that assigned for the second gear retrack. But so that's what I have right there. Okay, so let's get out of that, and then let's come here to back to model adjust, and let's go to the servo setup. Now, in the Inav Configurator, I had showed you for the gears for the retrack, under the output tab, I told you that you need to click that tab to do a reverse. But that is right here under aileron. You see that I have the section here reversed. This is the only place in the transmitter that you reverse a channel. I found that, and you'll see if I scroll through here, nothing else here is reversed. I have, whenever I found this also in my last build, that that when I had reversed it in Inav, so what happens is that whenever you connect everything up, your ailerons are going to be reversed. Left is right and right is left. You can reverse it in Inav, and it's right. But what I found is when I did my maiden on my last plane, whenever I took off and I was in manual mode, and when I took off and I put it in, try to put it in acro mode, the plane just spun like a top, and I was like, "Oh crap! It's going to crash this thing." And what it was is something about that reversing it and reversing the ailerons in Inav. It was backwards, and I didn't. You want to pick it up and do your test, for the stabilizer, the gyro test, and I obviously had it backwards in my head, and And I figured out, you know, when I brought it home, I was like, what the heck's going on? And I took the reverse off of iNav, and I came and reversed it in the transmitter, and it fixed it. Well, same thing happened whenever I was testing it here. I reversed it on, you know, I said maybe that was a one-time thing. I reversed it in iNav and didn't reverse it here. And I did the gyro test, and it was backwards again. So I turned it off iNav and I reversed it on the transmitter, and it was right. So this is the only place, or the only thing in the transmitter that you will reverse it. So if whenever you connect your plane to the flight controller, and if your ailerons are reverse, you know, make certain that you do the gyro test. Make certain that whenever you do it, that it's right. But for me, this is the only place that I do a reverse on the transmitter. Everything else you want to do on the flight controller. Okay. Also, you know, when we're talking about doing the range, when you're testing, you know, in the last video when we were adjusting the travel and the range, you know, we did the initial setup through the CLI, but then we want to do the fine tuning in here under travel. You know, we'll come in here and we'll start adjusting, you know, in here. Also, when you want to, you know, when you need to start, you want to do all of your physical control surface adjustments, you know, from the plane itself. But then you also you know, you still come in here and do all your sub trims and everything from the transmitter. And then your rates and expo, you don't do them here. You do them from the flight controller, from iNav configurator. So don't bother setting them up in here. This is another one, you don't do it here. You also don't use your trim buttons. You can, there is that is an advanced technique that you can do whenever you fly the plane, but you have to do it in manual mode. And but there's you know, but it doesn't take. So you know, when you're using a flight controller with iNav, you don't use your trim buttons. There's auto trim, and there's ways to do that and to save it, but you don't do those through the transmit. Okay, so basically, you know, that's it. Everything else is handled through iNav. Okay, I want to quickly show you how to calibrate the ESC. Now, the important thing is we need to make certain the prop is removed from the plane when we do this. And I do have the prop removed. So what we're going to do is we're going to come over here to Outputs, over here on the left-hand side of the Inav Configurator. And we're going to come down here. And we don't calibrate from the transmitter like you normally do. But everything else is similar. But what we do is we calibrate from the Inav Configurator. So what we do, make sure the prop is removed. We come right here and we click here, I understand the risk, and we click here, and this is the master slider for the ESC. And right now I have the battery unplugged, so we're going to make it you know all the way 100%. And the idea is the same as you would on any transmitter. You put your throttle to 100%. You plug the battery in. You wait for the beeps, and then you go all the way to 0, and then it's calibrated. So it's the same thing, except instead of doing it from the transmitter, we're going to do it from iNav. So here we go. So I'm going to go ahead and put it at 100%, and then I'm going to go to the plane. I'm going to plug the battery in. So here we go. Okay, so let's see how it is. All right. Okay, and I'm going to go ahead and unplug, but again, what we're going to do is we do a save and reboot and we're done, but that's it. It's that simple. So I'm going to disconnect the battery and then I'll do a save and reboot. And that's it. We calibrated the ESC. Okay, now that we have everything connected and we have the transmitter configured, we have iNav configured, everything right now is configured for line of sight. But I want to go ahead and show you what it looks like. You know, everything is tested. I'm by myself, so I'm not going to try to show you the gears because I don't have anyone here to record me, but just got everything thrown in here. And just for aesthetics, I'm going to go ahead and just put the canopy on. There's no FPV in there yet, but let's go ahead and show you. Everything right now is controlled with iNav. So we have up elevator, down elevator, right and left aileron. We have flaps. And we have rudder. And also, we have GPS. And since we have GPS, we can arm it. And so we have and I'm going to try to show you with the sun, but we have telemetry. Let me see here. Look here, we got, and there's a satellites. So we got GPS, and we'll see. We can see this stuff in the OST in the goggles whenever we're wearing them. So anyhow, just wanted to show you that. All right. Well, that's it. I appreciate you sticking it out with me through all of this. I know that it's a lot and a lot to digest. But you know, at the end of this, when it's all said and done, we'll have a plane that should be flying. We'll be able to do FPV. It's going to be great. Hopefully, I didn't miss anything. I want to be as thorough as I can. I don't want to go too fast where you watch this and say, "Oh, well, this is great. I'm glad he's having fun doing this," but I can't ever do this because I want this to be something that you can watch and follow me through, and then you do this, with me, and you can just run this video and just do it, and and have your own plane as well, because this is something that I think anybody can do. It's a lot of fun. So we'll see you in the next video, and I appreciate you watching, and please consider liking and subscribing. Thank you. Hey, welcome back to another video. We are this one's going to be a much shorter video. We are going to finish the last little bit of tuning. We're going to set up the modes that we need to do on the flight controller. We're going to do the arming, so that way we can put the Air Unit, the DJI Air Unit, into full power mode, and also to be able to engage the ESC and the throttle to be able to fly the plane. We're going to set up the return to home, and also the loiter function, which allows the plane to, you can put it in the loiter mode and the plane just sits there and flies around in circles. We're going to do some advanced, it's called advanced tuning in the Inav configurator. But basically, we're going to tweak some settings real quick on the loiter, if the loiter settings, and then basically, that's about it. This is going to be short and sweet. After this, the plane's going to be ready where we can do, if you wanted to just take it from there, leave it at that, and go do line of sight flying, have at it. That's not what the intention is. We want to put FPV in this plane, but at this point, after this video, the plane's ready to fly line of sight, but from here on, from this video, we're going to start messing with the canopy. We're going to be messing with the Motionsic BAG pan and tilt gimbal. We're going to be putting the DJI O3 Air Unit in. We're going to be setting that up. We're going to be messing with the DJI goggles, and then we're going to get ready to fly this plane. So, all right, so here we go. Okay, let's connect to the flight controller, and what we're going to do is, let's go ahead and start with setting up the modes. And the first mode that we want to set up is arming. Now, arming is the same as, the throttle cut, whenever you disarming your plane, without a flight controller. And that is, this is your safety. So that that if you don't engage your throttle, so your motor takes off on you. You hit your hand with your prop or whatever. With this plane right here, we got a GPS on it. We're going to have the DJI O3 Air Unit. You may be using another type of a video transmitter, but for us, for the Air Unit, for the DJI Air Unit, for it to be able to go full power, it has to have the arming signal to give it the full power. If not, it's going to stay in low power mode. And this is where it happens. So in the last video, I was telling you that, and we're going to jump back there real quick under the mixer. When I was telling you when we set up the servo channels, I was saying don't confuse the other channels from the transmitter. Don't add them here. You can see that we didn't add the channels 10 and 11 and 12, whatever. We didn't add those in here, but there wasn't any need. We added them in the transmitter. They were there, but what we did, we were going to put them in the modes. So here we are. For me, I'm going to use channel 10, and I already have it set up here. But so we come here and I say channel 10, and I'm going to flip the switch. For me, I'm using it on my transmitter on channel H, which is the far right. But I just flip the switch. It's just a two position switch, and depending on where you would want what the position of the switch is, you just basically would move the sliders to wherever it is that you'd want it to be. And you would see that it would be where it would arm. And you can see on the right here on the highlight here on the left where it says arm, it went blue, but I don't want it there. So I want it to be right there. So I'm going to move these sliders right here. So that is armed, and that is disarmed. So what would happen is, whenever we have the plane on the field, the GPS has to pick up the signal. The GPS has to pick up the satellites. So if it doesn't pick up the satellites, it doesn't matter if we do this or not. The plane will not arm. I can do this all day long, and even though we're sitting in an arming signal, Inav is not going to arm the plane. it won't, because it has a minimum of I think 6 satellites that it needs to be able to arm the plane. So we will, once the satellite, once the GPS picks up, the required amount of satellites, it'll be safe to arm, and then we'll flip the arming switch, and then, and only then, will we be able to use, the plane will be able to be active where we can engage the throttle. Just engage the throttle. So here we are. So the plane is now able to be armed. This is how we do it. The next thing we have here, the mode, we're going to go to flight modes. The default flight mode is acro. And acro is like, say for Spectrum, is like AS3X. It gives you your stabilization. And just think of it like that. And it's default. If you don't enable any kind of flight mode, that is there by default. What I do is I set up a manual. A manual is nothing. You have there's no stabilization. There's nothing. And I set it up on channel 9. And so let me just turn this off, and you can see when I turn it off, acro right here highlights, because that's the default. So that would be stabilization active. And what you want to do, especially whenever you're first doing a maiden, is you want to have a manual mode enabled, because what that does is it basically turns off all the INAV stabilization settings. Whenever I did my first maiden on my last FMS, or my last FPV build, I turned the acro mode on. I had the plane up. I was doing line of sight on the maiden, and I had the plane up, probably 150 feet, and I didn't do. Whenever I was first doing my, gyro test, on the ground, and I had to pick the plane up and doing left, right, whatever, watching how the aileron, the control surfaces moved. I had it backwards in my head, and I thought, oh, it looks right, but it wasn't. And so whenever I was in manual mode doing line of sight flying, and I, went from manual to acro, the plane started spinning like a top. I mean, like really fast. And I was able to flip it back into manual mode and recover the plane. But then I figured out, okay, that's a problem. So you do want to, when you do your maiden, you want to have manual mode configured. And honestly, I only fly in manual mode. I don't. It's just, well, at least on the other plane I do. I've flown in acro mode. And I guess it's fine, but I just always leave it in manual mode when I fly my other plane. So we'll see how this one does. I've never really seen any. I don't see any benefit of it. When I get up there and fly, I just always leave it in manual. But that's what acro mode is. Acro mode is basically your stabilization. But it's so it's like manual, but it has a stabilization, and then you got horizon, and I don't know, basically, like I said, I always use manual, but horizon is I think it's like acro, and but you can, but when I guess you take take your hands off the sticks, and it'll keep the plane level. I guess it's kind of like a safe mode, or maybe it's like an intermediate safe. And if you like try to roll it, it'll roll. If you try to loop it, it'll loop. But if you let go of the sticks, it'll go level again. So maybe it's like an intermediate, like say on your your trainer planes, or like your Spectrum receivers, where you have the the safe is like an intermediate safe, but it's not full safe. And I think angle mode is like safe. It would be equivalent to a safe mode where it limits your bank angles. But I don't. I think I've turned it on once on my other plane. I don't ever use it. Like I said, I only use manual. Maybe I should mess with acro, and yeah, I don't. Sorry. but here they are. But this is how you configure them the same way. I have it on, again, on channel 9. And yeah, so there you go. And basically, again, if you don't have any modes set, any flight mode set, acro is enabled by default. So you do need to set up manual. I mean, I need to stress that you do need to set up manual on a switch, so that way when you do your maiden, you do it in manual, so that way you don't have a snafu and lose your plane on your maiden. Okay, and I don't do any of these right here. And then you have your different trims. So what we want to do is we want to add I want to add the loiter and the return to home. So I'm going to add loiter. I'm going to put it on channel 11, and then I'm going to add return to home, add it to channel 11, and that's so I can manually do it. So I'll put them on. I have them on by switch D. So here is, I'm going to have them with nothing. This is going to be for my loiter, and this is going to be for my channel, for my return to home. And so, okay. All right, so that's all I'm going to configure right now. So I want to be able to have my arming, so that I can arm and put my air unit in the full power, and also so that I can engage the throttle and fly the plane. And then I want to be able to have my flight modes. So this is manual, acro, horizon. And then I want to have my loiter. So this is nothing. This is if I want to put in loiter mode, so the plane will just sit there and fly around in circles. And then if I wanted to do a return to home, there it is. Okay, and that's all I'm going to do for now. All right, and then we're going to do a save. All right, and then there's one last thing we're going to do on this video, and that is I'm going to adjust the settings for the loiter. We got a bigger plane, and these settings, I can't take credit for these settings. I got it from someone whenever I was setting up the my last FPV plane. It worked really well for that plane, and I may need to adjust it for this plane because it's even bigger. But we're going to go with these, and then we'll test it out and see how it goes whenever I test the loiter mode. But this is a good start. And what we're going to do to adjust the loiter settings is we're going to go up here to the advanced tuning. And this will be pretty quick and easy, and we're not going to mess with any of the auto launch settings, but we're going to come over here to the fixed wing navigation settings. And what we're going to do, we're just going to increase the loiter radius to from 7,500 to 8,000. We're going to change the navigation bank angle from 35 to, we're going to increase it to 45 degrees. We're going to increase the max navigation climb angle from 20 to 35 degrees. And we're going to change the max navigation dive angle from 15 degrees to 30 degrees. So we're going to increase all of this. And that's all we're going to change on this right here. It was a good settings for my last FPV plane, putting it in loiter. So we're going to do that, and then we're going to do a save and reboot, and then that's going to be it for the settings. And after this, we are ready for doing a line of sight. My transmitter's fussing at me. We're ready for line of sight flying. You know, for the plane, we literally could just take this plane out and fly it for line of sight. But we want to do FPV, so now it's time for that. All right. Well, this was probably the well, it has to be the shortest video out of all of them. Let's keep the theme going. I'll keep this outro much shorter. The next video we'll start getting into the actual FPV setup of it, and then we'll get ready to do a maiden of this T28 in FPV. All right, appreciate it, and we'll see you in the next one. Welcome to the last video before we maiden the Carbon Z T28 Trojan. In this video, we are finally putting the FPV gear into the plane. You're gonna see me come to terms with cutting the canopy up, how I decide how I'm gonna do it, how we put the Motionsic BAG pan and tilt gimbal into the cockpit, how I decide to put the DJI Air Unit into the canopy, how I'm running the wires. You know, it's still kind of messy. The only thing that we really have left to do at Inav is just to configure the OSD on-screen display. I'm using the DJI goggles V2, so I don't have my goggles rooted, so I can't, when I record anything on the goggles, I'm unable to record any of the on-screen display stuff. If I had them rooted, I could do that and show them to you, but I don't have them rooted. So anything that I do record or will record is just going to show you, just the recording from the Air Unit. But at the end of this, the plane is going to be, for the most part, it's going to be ready to go. There'll be maybe some minor stuff at the end of this video that I'll need to take care of, prior to the maiden. But as far as having the flight controller done, having Inav configured, and having all of the FPV stuff set up, it's going to be complete by the end of this video. So let's go ahead and get going on it. Now we come to the fun part. We're going to focus on the FPV part with the DJI O3 Air Unit and the Motionsic pan and tilt gimbal from the FPVdogfight.com website. So this is where we get a little creative. I had said in the very first video that, we're going to need to cut out the clear canopy, to mount this. I hate doing this. I'd like to keep it in there, but it's, to get hot, with how hot the Air Unit gets right here, it'll overheat. I do put a fan on it. We'll mount it, but I'm here in the southeast United States. It gets really hot in the summertime. So I'm going to pull up the other T28. I'm going to put it up here and show you, what I did with my last build, and talk about what I think I might do with this one right here. So here's the canopy of the FMS T28 1.4 meter that I had done on my previous build, and you can see where I have the clear plastic cut out. And, you can see the difference between the FMS canopy and the Eflite canopy. It's much clearer on the Eflite canopy. And the FMS canopy is really cloudy. You know, I had to cut it out, you know, regardless of if I wanted to keep it enclosed or not. It was just too cloudy all the way through. But we're gonna, you know, since they're both D28s, you know, I'm gonna do something, you know, very similar. One difference though is that the cockpit is much deeper in the FMS versus the Eflite. So that actually is going to be to my benefit, because I struggled with getting screws long enough to actually mount the pan and tilt gimbal in here. But, you know, basically, you know, we want to put this in how, you know, how the pilot's perspective is going to be, you know, also with where the, you know, eye level, you know, coming over the dash. And you can see here where I mounted the air unit, where I have the fan on top. There's airflow that's coming through the the windshield area here. That's all. That's, you know, that's flowing through, keeping the air unit cool. I also have, you know, an area cut out in the back for exit. It's probably not cut out enough, but I haven't had any issues with it, you know, while I'm flying it. Seems to go plenty fast enough, but, you know, it would do better if I cut it a little bit bigger. But so I'm looking at doing something like this, but I have more room to play with in the Carbon Z canopy, and seeing how it's so clear, I think I'm going to go a different route. What I'm thinking about doing, instead of cutting it all out, you know, I'm still concerned with how hot it gets here in the South. So, you know, regardless, you know, I've seen where people have put maybe an air scoop on top to allow air to come in, you know, so they can keep it fully enclosed, but allow air to come in, you know, in here, and have exits, you know, maybe cut out on the side here, or, you know, to allow, you know, air to vent out. I've also seen where, you know, put up here, like, so imagine the fuselage is right here, and you have, you know, an air intake, you know, coming in through here to, you know, to vent through. We could do something like that. But I think the route that I'm going to do is maybe not cut out all of this, you know, like I did with the FMS canopy. But instead, I think we're going to opt, because I've got so much room here, but maybe cut out like half on each side, so that way I'd still be able to follow the lines, you know, of the canopy, and it would still also give it the strength. Because, you know, when you cut out the canopy, I mean, it's, you know, it's not that rigid, but, you know, it would still give me those lines. You know, it's pretty clear. And maybe I can leave these three in here, and, you know, and I can test it. You know, I can, you know, when I mount the DJI camera in here, I can test it to see how clear it is. And, you know, then I can decide whether, you know, I need to remove these or not. You know, maybe I can just, you know, cut out the sides and go with that. But I plan on still mounting the air unit, how I have it back here. You know, here I still plan on mounting it back in here. You know, I'm not gonna put the antenna, you know, through the canopy like I did in the FMS. You know, I'm probably just gonna lay it back, so that way I can still keep these lines. Now this way I'm not going to cut all of the canopy out, and then I can decide, because this is pretty clear. But you know, I want to, you know, with the Air Unit, it has an SD card or the USB, depending on, because I record my flights, so I want to be able to make it easily accessible. There is a way that if I could extend this cable between the camera and the Air Unit itself, you know, I could mount it underneath, you know, so that way I could get to the recording, you know, from the Air Unit. You know, I know that I can record from the goggles, but you're not getting the full 4K. You know, if you record from the goggles, and I like to get the high resolution recording. So I think that's what I'm going to do. I'm going to try that and not have to cut away all of the canopy, so that way I can maintain the lines. So maybe I'm just going to cut out, and you know, and we'll see if that will give me enough airflow with the fan. And this right here, where I've got the Air Unit here mounted, it's something that I found on Thingiverse, and I'll link it in you know, in the description where I found it. But this is something that I 3D printed. It's made for the Air Unit, and I've already 3D printed one. You know, that I'll be, you know, putting this in, and it has a, you know, a mount for the fan, and you know, it'll all go in there, and then I'll just stick it in there. So I'm going to cut this out, and then we'll mount it all in there, and we'll hook it all up. I finished cutting out the canopy. What I did is I cut out right in here, and I also cut out the vents on this side instead of cutting it out on the back like I did in the other FPV build that I did. So I'm going to spin this around. So I'm hoping that it'll give me enough airflow. And here's a vent on this side right here. Then I'll mount the Air Unit here. I'll take the pilot out, but we'll see if there's enough visibility. And I'll test it. You know, with when I put the Air Unit in there, I'll see what kind of visibility I have, and what I'll do is I'll run it up to see if there's enough prop wash, you know, airflow getting through here to keep the Air Unit cool. If not, then what I'll end up doing is at least cutting, you know, if it starts to overheat, then I'll have to cut these plastic pieces out. But I'm hoping that I can, you know, at least keep like this right here and maintain the lines, and not have to cut the rest of the canopies out, because I think this looks pretty sharp. So, you know, now I'll remove this pilot and start mounting the Motionsic BAG pan and tilt gimbal with the Air Unit, and we'll start getting it installed. All right, I put the Motionsic BAG pan and tilt gimbal in the cockpit. I had to use all of the foam risers that was included in the kit that came from FPVDocbot.com. I had to put them in there to get where the DJI camera is going to be able to, you know, have full visibility over the dash instrument panel. It's pretty straightforward to install this. It's you know, how I did it is, you know, you want to center it, and you know, basically I poke 4 holes into the you know, to match, you know, the template of where, you know, where this is going to sit. And you know, these are the, you know, it comes with a nice set of hardware, but the bolts that comes with it is not long enough. You know, I like to secure this all the way to the other side of to the bottom, and I use it comes with another. Yeah, I put it on the bottom because I needed that extra height, but it comes with a piece of plastic, the same type of plastic here, but I needed extra height, so I put it here. Or else, I could have put it on the bottom here, but what I did instead is I made me some more using some hobby grade plywood, cut out using the same hole templates and for reinforcement, and I haven't tightened it down yet, because what you want to do is once you mount the camera in place, you're gonna want to adjust the, and I don't have it in here yet, but you're gonna want to see if I can get a good angle in here with the camera. Of course, the light's glaring off of it, but you're gonna want to adjust how level it is. So it's going to be, when you're looking at it, you want it to be level. So it could be kind of tilted one way or the other, or an angle. So you're going to adjust that level with those 4 screws. And so that way, when you're sitting in that cockpit perspective, and you're looking out over the instrument panel, you're not constantly looking at it like this right here, at a funky angle or something. You're not, something weird. So you adjust your level with those 4 screws. Okay, so the next step for me here is to actually mount the DJI Air Unit. Now, in the Motionsic BAG kit, they do supply a mount to mount the Air Unit, but I think it's for one of the older Air Units, and I've never used an older Air Unit, but it's not quite for this. And I was in my last build, I did mount the Air Unit to this, but I was using like double stick tape and zip ties to hold it on. But it has, get this off, it has these mounting holes, but they don't line up with what's on the O3 Air Unit, so it's not quite usable for me. So what I use is something that I found off of someone designed off of Thingiverse, and it mounts in here just great. It also has a mounting bracket for a fan, which you use a small computer fan and it mounts to the top, and then you're able to you supply power, and I provide power from the Speedybee flight controller, and it's constantly getting some airflow over it, and so that works out great. So that's what we're going to do, and my intention is to put the Air Unit is to mount it back here. And the way that I cut out the canopy, I'll still be able to get it and to move it around. And I'm just going to Velcro it there so it's easy to move. All right, so that's going to be the next step, is I'm going to mount the Air Unit, and the Motionsic BAG gimbal set comes with the necessary hardware to mount the camera to the pan and tilt gimbal. So I'll mount that in there, and then the next thing is to connect it to the flight controller and set it up. I would like to mention also that the bolts that were supplied with the Motionsic BAG gimbal, these bolts weren't long enough for this to go through all the way through this canopy. And what I ended up using, I got these off of Amazon, but I ended up using the M3 by 60 millimeter bolts. Those were exactly what I needed. The M3 55 millimeters was too short, but the M3 60 was just right. So if you are doing the same build, you're going to need to get something much longer, and the M3 60 was exactly what I needed. And also the pilot that is inside this thing, this is screwed on, but it also, they glue it so that it stays in there. And if you can see here, it takes some of the paint And I don't know, the paint code, but I tried to mix some Vallejo colors to try to get it to match. I kind of eyeballed it. It's not perfect, but it does a job. I'm not going to go in here and repaint the inside of this canopy. And once this build is done and I get a couple of flights under my belt with this, I may come in here and try to make it more scale. Do some weathering. I may do more of a more fancy instrument panel instead of the stickers. But right now I just want to get it get it flying, and then I'll come back and make it look better. So I'm not really worried about it at this point. I just don't want to see the white foam underneath like it was when I pulled the pilot out. So I just wanted to say that I don't know what the matching paint color is that Eflite has here, but I did had some Vallejo paints. I tried mixing them, trying to get the right colors, but it was just still a little bit too dark. Here we are on the inside. Try to clean it up a little bit. I want to point out that whenever you have everything connected and you're working in iNav and you have your plane powered up with the battery and you have it connected to iNav, you always need to have your pan and tilt gimbal disconnected. The reason why is whenever you do a save and reboot, for some reason I have found that if it's connected and you do a save and reboot, your pan servo will just start spinning around at 180 degrees, and your servo wires will just start wrapping around the gimbal, and then it'll lock itself up. So just as a safety precaution, disconnect these servo wires, and everything else I've always found to be fine. But whenever you're doing that, just disconnect them. But yeah, this is about as clean as I've been able to get it. I've mounted the receiver in the back. Whenever I get it to the field, I'll do my range test. It is tail heavy. There's a lot of room to to add more weight up front, but it is extremely tail heavy right now. So I may end up buying another maybe a heavier battery. So we'll see how it goes. Right now, the weather has been. We've had a lot of extreme weather here. A lot of fronts moving through, so I'm going to be delayed, probably flying this for maybe another week or two. So this will give me time to either order another battery, or maybe I can fit another 5,000 in here, and it gets some longer flight time. We'll see. It may be too much weight up front to do that, for the front retract, for the front gear, but I'll figure something out. But right now it's looking good. We're done. Also, whenever I was earlier, when I was cutting the canopy, I wanted to keep the line, to keep the lines. I was wondering if keeping the front plastic in, how it would look, if it would be too distorted, and also if the DJI Air O3 Air Unit, if it was going to overheat. It was overheating. I was running the prop. I wasn't flying it, but I was just sitting in the backyard and I was running it, but it was still overheating. So it looks like I'm still going to need to cut these out, but it was very distorted, or it wasn't very distorted, but it was distorted enough that it would get annoying to me. It wasn't so bad on the front windshield. So I may just cut these out and try again. The it still looks okay here, but it was still a bit distorted. You know, going from super clear to up here, and this line here on both sides was pretty noticeable. But I could get used to it. I do like being able to keep the line of the of the canopy. But I think what I'm going to do is I'll cut these out and see how that does, if that's enough. I still need to bring the antenna up, get it off, where it's laying. I may end up doing what I did with the other FPV plane and just drill a hole and have it sticking up and let it be a little robot looking T28 with a little funky little antenna sitting up there. But it really looks good, with all of it. It's looking really good. I'd like to show you real quick how to set up the head tracking on the Spectrum radio. Now, the owner of the Tally-Ho head tracker from FPVdogfight.com, he has a really nice tutorial on his website that he shows you how to do this. But I'm gonna quickly show you how to do this on the IX14. It also is the same for the DX and the NX radios. I'm not going to go through on how to set up the how to set up the head trackers on the goggles, because that's you'll need to do that if you whatever head tracker you order. But this is how you actually set up the head tracker on the goggle, on the transmitter itself. So what you do is you're going to go to model setup, and then you're going to go to trainer, and then you're going to go to wired trainer, and then you're going to proceed to turn off the RF, and make sure it's on FPV. You have the different options, but make sure it's on FPV. And then you're going to choose your switch. I use switch F. That's the switch that I use. And whenever I am not in head tracker mode, I keep it, it stays in instructor mode. And so this is in one of the earlier videos, I was saying, I have the channel 7 and 8 assigned to my rear slider switches. So that way, whenever I don't have the head tracker turned on, I can just control the pan and tilt from the slider switches on the back of the transmitter. So, but I have it assigned to my channel F. You can assign it to whatever channel you would like or switch you would like. And then all you got to do is say, all right, what output channel? So I go to auxiliary 2 because you have them assigned to auxiliary 2 and 3. And then what you do is you change the mode to student. And the input channel is channel 7. And you're good. And then you change the next output channel to auxiliary 3 and change that mode to student, and the input channel to 8, and then that's it. That's all you have to do. And then you can back out. And then what happens, I'll move my transmitter down here, is I have it on this right here. And so whenever you have your head tracker connected, and I'll show you here in this, you use a cable, and it goes onto the back of the transmitter right here. Whenever it's connected and everything's powered on, you flip the switch.
No student signal.
And whenever you have everything connected.
No student signal.
Let me see, I can turn my goggles on.
No student signal. Student control.
There you go. So I have my goggles turned on, and so that it's and then I'll have it here in just a second where you can see the goggles controlling it. But so everything's controlled by the switch, and so whenever I'm in head tracking mode, you just flip the switch, and then the head tracker on the goggles controls the pan and tilt on the plane. And then whenever whenever I land and I want to turn that off, I just flip the switch.
Instructor control.
Then whenever I want to control the pan and tilt with the goggles, with the head tracking.
Student control.
And there you go. All right, now that we set up the head tracking control on the transmitter, I want to show you how it looks. So I'm sorry that I don't have the professional recording videos here, but this right here is the Tally-Ho head tracker that I purchased from FPVdogfight.com. Right here, it attaches to my DJI goggles V2. Now, if you have the DJI goggles Integra or the DJI goggles 2, they attach to right here to the front, so they attach differently. So I'm gonna be picking up the camera, and we're gonna put it right here by the plane so you can see it. But what we have is on the transmitter. What we did is we set it up on the F switch. This is where I like it. And right now, nothing happens. I can move the goggles around. Head tracking doesn't work because it's in instructor mode. And there's a wired cable that plugs into the trainer port, or the serial port at the back of the transmitter. Now, if you're using not a Spectrum radio and you're using like an FR Sky radio, you can actually connect this head tracker wirelessly. So there is a benefit to going to FR Sky because you can do this wirelessly. But we're not doing that, or I'm not doing that. So what we're going to do is I'm going to flip this switch and I'm going to put this into student mode, which is AKA head tracking. So we're going to flip the switch.
Student control.
All right. So when I do that, we need to center the head tracker. So whenever you're sitting, you're sitting on the field, and you get yourself, you're sitting in the pan and tilt was moving around. You're sitting in the position that you're going to be sitting in to fly the plane. There's a button on the front. So what you do is you push that button, and it centers the pan and tilt. And then you're looking at the front of the plane. And I mean, I can kind of see if I can get this to look to the you can see when you're looking through the plane here. All right, so anyhow, so right now when I move, everything is looking, pan and tilt's going. So now we're going to pick up this camera and we're going to see the magic happening. So here we are. So I'm moving the goggles up and down, right and left. And now we have FPV. Everything's working. And that's really all there is to it. The only thing we're going to need to do in Inav now is set up the OSD. And this is the on-screen display for your goggles. And I use the DJI goggles version 2. This takes a second or two. Or three. Okay. So what we do for DJI is we have the unless you've rooted your goggles for the DJI goggles version 2, we can put them in the Betaflight compatibility mode, and you have two options here: the regular 4.3 version or the Betaflight HD compatibility mode. And you know, I've tried using the HD compatibility mode on my goggles, and the on-screen display components just do not look good, and I just can't get them to fit the screen right. So I use the Betaflight 4.3 compatibility options, and so that's what you're going to want to select. If you have your goggles rooted with the, I think it's the WT FOS, I think that's what it is. My goggles aren't rooted. If your goggles are rooted, you can record the on-screen display, and you know, you can view those on the screen. But I don't do that, so I can't share that with you or show you how that works. So I'm just going to show you what I do. So I use the Betaflight 4.3 compatibility mode, and you have all these different options that you can put on your you can view on your goggles. And I don't busy my goggles up with too much. I like to see, you know, my regular cell voltage, the full battery voltage, and it's not. I mean, I say it's fairly accurate. You know, it's not fully calibrated. I know there's ways to calibrate, you know, what Inav is pulling from your flight controller. You know, there's been times that I've flown my other FPV plane, and it's, you know, I get kind of scared. I'm like, oh no, I got to land this plane right now, you know, and I'll land, and I'll check the battery, and I'm like, oh, I could have flown for probably, you know, another 3 minutes or so. And, you know, so I think it's, you know, it's, my battery's probably sagging from, you know, what I'm doing, but you know, I think you know, if calibrating it, I need to learn how to do that. But so what I have on mine is, you know, the single cell voltage, the full battery voltage. This is your distance from your home, from when you take off, the direction of home. Your heading. It's just getting the information from your GPS. This right here is your RSSI signal strength. You know, from your receiver. This is your throttle percentage. You know, from your transmitter. So this right here would be like, you know, you can look up here, and so this is like you have 69% throttle that you're using on your transmitter. This is your altitude that's measured from your GPS, and this right here is your measured ground speed from your GPS. So don't confuse this with your you know, your airspeed. You know, unless you've, you know, using a, you know, have a pitot tube on your model. This is measured ground speed. So when you're flying, you're like, oh wow, I'm doing, you know, 70, 80 miles an hour. Well, no, not really. This is just what the measured ground speed is that the GPS is measuring. Also, you're looking right here. I have set up how many satellites the GPS is picking up, my flight time. This right here, where it says acro, it's picking up or telling you what flight mode I'm in. System message is any kind of messages that iNav is telling you, on screen. You can read them, in your goggles. I have my, my crosshairs here. I have my Vario, and so but how you put these on here is you can scroll around on the screen here, and you just choose what it is that you'd like to see. And you have all these different options. I'm just going to peruse through here real quick. And there's a lot. I mean, you can busy your screen up. And yes, let's say for example right here, I'm going to go to the first one, the RSSI signal strength. And if you look right here is where it was. Let me turn it back on. And if what you do is you can place these widgets where you want them on the screen. So if you don't like it here, you can move it somewhere else. And then whenever you're happy with how you want them, you can just click save, and there they are. But I like it right here. That's why I hit save. And so you can, depending on the type of goggles that you have, and I can show you here. Like, let's go here to the Betaflight HD. So like, hey, you got all this real estate right here. But on my goggles V2, I can place this all around here how I like it, but it doesn't look at it. If you have the the goggles too, the goggles Integra, I think this would look really good. But for mine, they do not. So I'll put it back here. And that's it. This is all we're going to do here in iNav, and we're done. The rest of it is we're on the plane. But what you do is you have your have everything connected in your plane, and if you want to when you're setting this up, you just have your goggles powered up, and move these things around, and just look in your goggles to see if you like how it looks, because you can look at it, just move it around, hit save, then look in your goggles, with your plane and all powered up, and say, okay, yeah, this looks good, and then you continue on. Okay, what I found in doing this, I wanted to keep the lines of the canopy. I don't want to have to cut it all up, and I found that the front of the canopy, by not cutting the plastic, out of the side window panes, it was still distorted for me. It was, when I put it in when I armed the plane and put it into full power mode, even running the prop, it wasn't getting enough airflow. It overheated almost immediately. I was trying to record it. I don't know how much I was able to get. So, whatever I was able to get, I'm going to, I'll have it all included so you can see. I will, most definitely, I'm going to be cutting up the canopy a little more. There's still some more tweaking I'm going to do. The center of gravity, the CG for the model is quite tail heavy right now. So actually is a good thing for me, because I would like to be able to have longer flight times. So this means that I can put, a heavier battery in this plane. So I can, I'd like to be able to have, 10 plus minutes of flight time in this plane. And if I can get, even close to that, I'm going to be happy, because it's when you're flying a plane line of sight and you get, 5, 6 minutes, then hey, that's great. But when you're flying FPV and you only get, 4 or 5 minutes, it's like, oh wow, that happened really fast. So if you can get, 7, 8 plus minutes, oh, that's great, but even that's going too fast. So if this thing's tail heavy and I can put, some, heavier battery in it, so to get me more flight time, I'm going to be happy with that. hopefully I won't have to wait too long to get the maiden flight up to you. Like I said earlier, the weather's been, it's the beginning of spring. There's been a lot of fronts moving through. I'm here in the southeast United States, so it can't decide if it's going to be cool or if it's going to be warm. And so it gets cool, and then it wants to be warm, and then it gets cool, so we get storms and a lot of heavy winds, and so that's preventing me from doing anything. So hopefully we won't have to wait too long before I get that maiden up to you. But until then, I appreciate you sticking with me in these videos. Hopefully I was able to show you something. Hopefully I didn't bore you too much with it, but this has been a pretty fun journey for me. This is going to be a really nice plane. When I've taken it outside and put the goggles on and looking around in it, I mean this is pretty sweet. It's a good sized plane, so I'm really excited to take it out and fly it, and I'm looking forward to sharing that experience with you. So I appreciate it, and I'll see you at the maiden. I recently had someone request to show how I have my settings set up on my DJI goggles V2 when it comes to how I'm recording my videos. They have a setup like mine, with the same type of Eflite carbon, the T28, the 2-meter plane. I noticed that they're posting their videos on YouTube, and they're posting them at 1080p, and I'd asked them, where are you recording your videos from, and they're recording their videos from their goggles. And so this is just a quick video on how I'm doing it, and where my settings, how I got my settings set up on my goggles, and how I'm recording them. And you do have an SD card that you do have that you can put in your goggles, right here. And I do keep an SD card in here in the event that it is recording. In the event that if I was to lose the plane somewhere, I can go back and view the recording to help me find it. But the resolution in here is not something that I'm going to want to upload to YouTube and to show my videos. So I'm going to just real quickly show you what I do. Come here to settings. Come down here to about. I'm going to go all the way here to the bottom, which I'm just going to hit up, and it goes onto the bottom. And right here where it says switch aircraft model, it's something that I didn't show in my original tutorials. You see where it says DJI O3 Air Unit? I'm going to select that. Here are the different options that you have here. You got DJI FPV, the DJI digital FPV system, the Avata, and the DJI O3 Air Unit. Since we're just using the Air Unit, this is what we select. So we don't have as many options, but this is what we have. So we're just going to leave that. All right, so let's go up to the camera, and I leave it at mine at. If you go to camera parameters, so I leave it at auto, because I don't mess with any of that, because I don't have any, I do all my video editing on either my iPhone or my iPad. Back out of that. All right, let's go to aspect ratio. I keep mine at 16:9. You could use the 403, but I'll leave mine at 16:9. As far as video quality, when I fly, I'm flying mine at 4K resolution, 60 frames per second. These are the different options you have, but I have a very good latency. It's not noticeable when I'm flying. This is where I'll leave it. And I use the Rocksteady for stabilization, video stabilization. So these are parameters that I use. This is everything that I use right here. And right here, under channel mode, I'll leave it on auto. Now, if there's other people at the field with you, if they're doing FPV, you would want to come in here to manual. And you'd want to change your, you'd want to change your channels, to something different. If you were, to make certain that y'all are on top of each other, so that way you'd lose video. Those are the settings. Very simple. O3 Air Unit. It does have onboard memory that you can record to, but I don't want to have to hook the USB cable up to this thing every time that I want to download my my videos. So I keep an SD card in here, and what I do is after I finish flying, I bring this thing home. I pop this little card out, and you can see that it's right here. I pop it out, and then I connect it to my computer, and I pull the videos off, and that's where I edit them from. And so as you saw from my settings, in the goggles themselves, I'm recording at 4K 60 frames per second, and this is where the video recording is what I use to upload to my YouTube videos. So you can see it's not a hard setup. I do have two SD cards that I do use. I put one SD card in the plane, in the Air Unit, itself, and that's where the 4K 60 frame per second resolution is. That's what I use when I make my videos and I upload them. And then I do keep, for the low resolution, I do keep it in the goggles right here. And that is in the event that if I was to lose the plane and it was to go down to a field, I could go back and look at the recordings, and it could help me, hopefully help locate the plane. But that's it. All right, hopefully that helps. If you have any comments or questions, just post it and I'll reply. Thanks. All right, so we're right here. We're gonna finally try to do the maiden on this. We're gonna do a line of sight maiden. Once everything is trimmed, then I'll do the FPV maiden. So it's a little windy. I've been waiting for the winds to calm down, but I don't think it's gonna get any calmer than this. We've got about 8 to 10 mile an hour steady winds, gusting at about 12 to 15, but this is a big enough plane to handle it, so we're gonna go ahead and do the initial maiden. I'm going to be flying it with a HRB 5000 with Success battery. I got it to balance out. Here's the inside. Okay, I'm going to take off in manual mode. flat. Landing gear up. Put it in macro mode and do an auto trim. Auto trim.
Okay, I can't see. I can't even tell if I've got it in the frame.
Bring that back. Bring it for a landing.
Again, I can't see if it's in the.
I just kind of bounce it. All right. That was a good maiden. Okay, I just had a successful maiden line of sight, and now I'm getting ready to do the first FPV flight. So, see how that goes. Recording. Yep. Try to stay over it. Okay. I'm gonna come fly down the runway. Okay, so I just got the first FPV flight in, and it flew straight and level. I had no issues with it. It flew great. It was a successful maiden on the FPV. I'm getting ready to do another FPV flight on it. It's a great flying plane.